hope it has started. Yeah, yes.
हेलो, am I audible?
Yeah, yeah.
अ, जैसे मुझे एक डाउट था कि ये अगर कोई वीक 8 से वीक 12 तक मान लो कुछ नहीं पढ़ा हुआ तो उसके लिए
Okay. Week 8 to week 12. See, I'll
हाँ,
tell you, graph theory is easy. But if you have some experience with integration differentiation, well and good. But if you don't have, I'll tell you, study the basics. Graph theory, you will do it. It is not that tough. You will face some difficulties in limits and that.
उहुँ,
So I'll take some questions, I'll cover that, but you also need to practice by on your side because it needs some practice as well.
मुझे डिफरेंशिएशन आता है बट इंटीग्रेशन में इश्यू है।
हाँ, तो डिफरेंशिएशन आता है, then integration is easy. We'll see that also. Okay. Are the slide is the screen visible?
Yes.
Okay.
यस,
So week one is all about sets. For week one is all about sets. Now, what are sets? Anyone who? Yes, yes,
हेलो,
yes.
A well-defined collection of objects.
Collection of objects, right? And it will not have unique. It will not have repetitive elements. It's always a unique set. It's always unique collection, right? Now, for us in Max, we have some predefined sets. The first one is the set of whole numbers, which are all the numbers of greater than or equal to 0. That is 0, 1, 2, 3 till infinity. All the whole numbers. Then we have a subset of it which is natural numbers, which is same as whole numbers except that we don't have a 0. We start from 1 and we go up till infinity. Now this is the positive side of axis. What about the negative side? We have integers. Here we start from minus infinity and we go up till positive infinity. So this covers minus infinity till minus 2, minus 1, 0, 1, 2, and then we go till infinity. Right? After this, these are just specific points. What about the number between minus 1 and minus 2? Where do we put minus 1.5? We don't have an option to put them in any of this. So we developed another set which is called as real numbers. Now real numbers are all numbers on the real number line. Now this consists of rational numbers, irrational numbers, and any other type of number we know except complex or imaginary numbers. What are rationals? Numbers that can be expressed as p by q, and irrationals are number that cannot be expressed as p by q, cannot be expressed, right? So one question they generally ask is this root 2 a rational number? Is root 2 a rational number? Yeah, you can directly just open your mic and say
No.
no, right? Why? Because this cannot be expressed as p by q, where both p and q are real numbers. Not real numbers, sorry, integers. Right? Root 2 is not an integer. Similarly, can you identify this pi as a real number or as a rational number?
Yes.
Pi is a rational.
Yes,
Mm, why would you say so?
because it is written in the form 22 by 7.
Okay. Pi is approximately 22 by 7. It's this approximate that creates a problem. So this is also not a rational number. This is also an irrational number, right? Because we don't know the value of pi. We know it is 3.14, but after that, there are so many digits. So this is also an irrational number.
Okay,
So these were the predefined sets that we need to remember. Now we have something called as subsets. Subsets. Let's say I have a set. Uh, okay, before that, let me take the notations. Okay. So the first notation is the simple notation that we use is directly writing the values. This is 1 2 3 4 5. This is a set. This is one notation of it, right? After this, we have another notation which is set builder form, where we write the elements in the set as, let's say there is an element x such that x belongs to a universal set. I'll prefer to, let's say I take integer. So I'll write x belongs to integer set. Okay. Yeah, recording will be available. Okay. And let's say my x should be less than 5. This is the same thing as this, right? But this is a set builder form. This is the simple set form that we use. These are two important notations. If you don't know the name, it's fine. But you should know how to convert them from one to another. Is this fine?
Yes.
yes.
Yes. Then we have set theory. Now, what does set theory say? Anyone who would like to volunteer for this? We can, in this set theory, we introduce some terms such as cardinality and all of that. What is cardinality?
The number of elements in a set.
Yeah. Elements in a set. Count of elements in a set, number of elements. Correct. Now, there are two types of set: finite sets, infinite sets. Now, for finite sets, cardinality is a number. Cardinality exists, I can say, right? But for infinite sets, cardinality does not exist. Does not exist. Now, now we come to the notation of subset. Let's say I have this universal set. This is my universal set. Now, in this, I have some elements that I take and form another set. Let's say T. So now this T is called as a subset of my universal set, because I'm taking my elements from universal set, I am filtering some elements out, and I'm telling that this belong to T. So I can say that T is a subset to universal set. Subset to universal set. Is this fine up till now?
Yes, absolutely.
Now then we have, okay, then we have two term in two terms. One is subsets, other is proper subsets. Proper subsets, okay. Subsets are, let's say this T can be a subset of this universal set. So will I include the whole universal set as a subset of T? Uh, okay, let me frame it in this way, that if I have this T, correct, can I say that this whole universal set is only T?
No.
Okay, I'm asking for subset, right? So for subset, no, we can say that T equal to U. T equal to U will work here. But in case of proper subset, my T is never equal to U. This part is a bit confusing. Let me write it this way, that in proper subset is never equal to its parent. Subset is never equal to parent. Okay. Now is empty set. This is an empty set. Is this, can I say that this is a subset of my universal set? I have defined a universal set. Let it be anything. Can I say that my empty set is a subset of universal set? No. Okay. Anyone who feels that yes, I can say that my empty set is a subset of universal set?
Yes.
Yes. Okay. See, I'll tell you one thing. Let's say I have this universal set as 1, 2, 3. Right? Now the choices for my subsets are, I'll take 1. This is a subset S1. My second subset is, I'll take, let's say, 2. My third choice is combine this to take 3. Take 1 comma 2. My fourth subset is, let's say, I'll take this 3. Fifth subset is, let's say I combine this two, I'll take 2 comma 3. My sixth subset is, let's say I'll combine 1 and 3, and I'll take 1 comma 3 here. Or another choice, let me take all of the 3 and write 1, 2, 3. The last choice I have is, let me take nothing of it and my set will become empty. Right? So empty set is also a subset of my set. Right? After this empty set is my subset. If you see this example, can you see that I have 2 raised to the power 3 subsets, or I have 8 subsets, right? I have 8 subsets for a set with cardinality 3, correct? Cardinality 3. Now this 8 I can write as 2 to the power of 3. So I can see a relation that if my A is a universal set, A is a universal set, right? And A is my cardinality, or alright, cardinality is N, then number of subsets. Okay, number of subsets means the set is contained in the subset. So number of subsets is 2 to the power n, right? Now then we have the concept of power set. Right now we studied subset, empty set. The concept of power set is power set. Let me take another color. The power set, what it says is the set of all subsets. Now this is a set of sets. So if I have A as 1, 2 and 3, right? The power set of this will be 1, 2, 3, 1, 2, 1, 3, 2, 3, empty set, and 1, 2, 3. Right? This is called my power set. This power set, okay, this power set is fine. Now what they can ask you is, what will be the cardinality of power set of A? Sorry. What will be the cardinality of power set of A? So how will we find it? First we do power set of A. What is the cardinality of power set of A? Anyone? 8. Now what will be the cardinality of power set of A? Basically, let me take this power set as B. Consider a set B that has 8 elements. Now what will be the power set of B? It will be 2 to the power of 8. Right? I hope that this concept is clear. Even though it is a set of sets, you don't have to worry that what will happen with set of sets. You just consider that this is an element. I'm using it alone. Right? Then we come to set operations. Only 3 or 4 operations, not more than that. First is union of sets. I'll draw the Venn diagram and it will make the life simpler for you. Set operations, right? Let me consider two sets A and B. Okay, I have two sets A and B, and they are from universal set U. A and B are subsets of U. Okay, so that means I'll have this diagram which is like this. I'm considering that there are common elements between A and B. Okay, now I'll take let's say purple color. I'll tell A union B. So if I say A union B, I mean the elements in A as well in B. This is A union B. Now for A intersection B, let me just copy this out. Now what will be the area that I'll take for A intersection B? For A intersection B, my area will be this part, the part which is common to both A and B. So I can write this as elements in both A and B, right? This is A union B. This is elements such that they are common elements. Third is we have A minus B. If you have this, A minus B means elements in A but not in B. But not in B. So that means only this part, right? And similarly, if you have B minus A, if you have this B minus A, let's say with red color, then I'll take elements in B but not in A, which is this part. Okay, is this fine? Right, I am taking this silence as yes. Now,
Yes.
yeah, thank you. Now we have this formula. We have this formula for working with sets. Let's say I have this as A and this as B. Now we have a formula which is n of A union B. N is the cardinality. I can calculate this using a formula which is n of A. Now look this very uh, carefully, that if I am taking n of A, I am taking this whole thing, right? N of A. Then I am adding n of B. N of B. Right? Now since I am adding n of A and n of B, this part, the one that I am shading, comes 2 times. Right? So I have to remove that once. So what I'll do? I'll subtract n of A intersection B. Correct? Now this is your formula for 2 sets. Something with 2 sets. Similarly, we have a formula for 3 sets. Let's say I have this, this and this. I have this 3 sets. Now for the union of these 3, NA union B union C, this is equal to the first set as a whole, n of A, then a second set as a whole, n of B, right? And the third set as a whole, n of C. Right? Now similarly here, this part comes 2 times, right? This part comes 2 times and this part comes 2 times, correct? So I'll subtract them one by one. So let me subtract n of A intersection B, n of B intersection C, n of A intersection C. Now, if you see that when I subtracted it the first time, okay, let me do this again. Right, first I took this, then I took this, and I subtracted this whole thing, correct? So that means what I have left, or what my resultant looks like for this two, is this thing and this thing, correct? Then what I did was I took this thing, and I subtracted this part and this part. So what I did was I took this part, this part, this part, and one times of this part. But what I did was I subtracted this thing. I subtracted the shaded region 3 times. Now this is not what I want to do, right? So what should I do? I should be adding the intersection part once again so that it balances out my formula. Right? So what I'll do is I'll write n of a intersection b intersection c. Is it clear? Right? So if you want to remember the formula, what we do is we take the cardinality of odd number of sets minus n of even number of sets. Now by sets I mean the union and intersection here, sorry. So this is n of a, n of b, n of c, n of a intersection b intersection c. If I have a fifth set, I'll do n of a intersection b intersection c intersection d intersection e, right? And by odd mean, by even number of sets I mean this terms. Okay, this is the generalized formula: odd number of sets minus even number of sets. I hope this is clear. Now the questions that come from set theory are based on this topic. They are every time based on this topic. I hope these sets are clear now. Anyone, anything to ask? Mm. Now, after this sets, if we have one set, I can multiply it with the same set, right? That is called as the Cartesian product. Cartesian product is just pairing of elements of one set with another. One set with another. That means if I have something like a set A, I have something like A which is 1, 2, 3, and I have set B like 5, 6, correct? And I want to find the Cartesian product. I can write this Cartesian product as the set of all elements in of the form A comma B, where A belongs to set A and B belongs to set B, right? This set builder notation. If I want to translate it into my simple sets, I can write this as the first element of set A gets paired with the element of set B. So this is 1 comma 5, 1 comma 6, 2 5, 2 6, 3 5, and 3 6. Clear? This is Cartesian product. Now when I apply some filtering condition on my Cartesian product, okay, when I filter this, then it becomes a relation. What do I mean by filter? Let's say I want my Cartesian product of be the same form A comma B, but what I want is I want a condition on, let's say, A, that my A should be less than 2, right? If I apply this condition, what will happen that A should be less than 2, right? So this 4 elements will be removed from my Cartesian product, correct? Now this becomes your relation. I hope this is fine. Now from there we go to relations function, but I think function is covered in week 4 or 5, right? So I'll just stop here for week 1. Anyone having any doubts in week 1? Any question of week 1? Anything like that? If you don't have a doubt, let me just take a question.
No doubts.
No doubts? Okay. Just give me 1 second. I'll get a question if I have. Mm, okay. Let's say I have this Venn diagram where I have 3 sets. This is max, this is physics, and this is stats. Okay. Then I have this as A. I'll write it A, B, C, D, E, F, G. This is a notation. I am just assuming regions, right? This A region means only this part, not the boundary. Okay. Now I'll tell you some statements. Just clarify whether they are true or not. D is the set of students who have taken both maths and stats. Hmm?
No, sir.
No, right? Okay, then this D union E union F union G is a set of students with minimum 2 subjects who have taken at least 2 subjects,
Yes.
right? D, F, G, and E. That means this part, the intersection. Then we have E is a subset of students who have not taken max,
Yes.
Yes.
correct?
Yes.
Now I have max minus D, right? I have max minus D is the set of students who have taken only max.
Yes.
Think about it,
Acha, max minus D. I
No,
thought
no.
max minus B. No.
right? So max, if I have to find the students who have taken only max, I'll have to remove this part, and this part.
Yeah.
Okay, and then I have physics minus D union G union E is the set of all students who have taken physics. Hmm,
D. E.
okay.
Yes.
Yes, right?
Hmm.
Right. So I hope this is clear.
Hmm.
Yes, sir.
Yeah. Then we'll move on to week 2 then.
Okay.
Week 2 is all about geometry now. Okay, then I just cut it out. Yeah. Week 2. This is about linear geometry. Okay, then rectangular coordinate system, right? This is what we call as rectangular coordinate system. This is the y-axis, this is the x-axis, right? Now, oh sorry, this is the y-axis, this is the x-axis. This point here, this is an important point known as origin. Origin. This is 0, 0. If I move this side, I increase this part. If I move this side, I decrease this part, right? Similarly, if I move upwards, if I move, let's say here, this path, I'll increase this 0, the second 0. And if I move down this path, I'll decrease this 0. So as such, any point in this geometry, we write it as x comma y. This is the x coordinate, this is the y coordinate, right? Now if I want to find the distance of this point from origin, that means I want to find the distance of this line, the pink line. How will I find it? Now if you want to derive this formula, I can derive it. If you want it direct, okay, let me derive it first. So what I do is I drop a perpendicular, right? I drop a perpendicular to x-axis. So what I have is x comma 0, correct? How many of you agree with this point? I hope you all agree. Yeah, Radhan Para. Okay. Now similarly, I'll drop a perpendicular this side as well. This I can write as 0 comma y. Now since I want to find the length of this side, correct? What will be the length of this side? Okay, before that, can I see that? Can I say that this is a right angle triangle? So can I write this thing? I can apply the b square plus p square property, the hypotenuse property here, correct? The Pythagoras theorem. Now when I apply the Pythagoras theorem, I need three things. Two things out of these three. The value of base, the value of perpendicular, and the distance of hypotenuse. I need any two to find the third one, right? I want to find this hypotenuse's length. So I need the base and perpendicular's length. If you see, I have been given this point and this point. This is x distance, right? This is just x, correct? And similarly, this is just y, right? So I can say that x squared plus y squared is equal to OP squared. OP here means the distance of the point from origin. This is O and this is P, right? So OP is equal to root of x squared plus y squared. Now this was when the other point was origin. Similarly, to find distance between 2 points, uh, distance between 2 points, I can use the formula which is difference of their x coordinates squared plus difference of their y coordinates squared. Just remember one thing, if you are taking this as 2, This should be 2. If you are taking this as 1, this should be 1. The order here matters, nothing else. I can also write this as x1 minus x2 squared, y1 minus y2 squared. Okay, this is your distance formula. I hope this is clear. Yeah. Then we have something known as section formula. I have a line a comma b. I have a line a comma b, and I want to divide this in, let's say, m is to n ratio. So where should I place my point P? This is my question. Let's assume that this A is at x1, y1. Let's assume B is at x2, y2. I want to find the value of P, x comma y. Right? For this, we have a simple formula that P of x comma y is equal to mx2 plus nx1 by m plus n. Right? And similarly, for the y coordinate, we have my2 plus ny1 by m plus n. I hope this is easy enough to remember. Just take this, multiply it with this. Take this and multiply it with this. Right? Now, if I this is a general formula. If I try and specify that my m and n, or I want my line to be divided in midpoint. I want my m is to n to be 1 is to 1, right? What this means is I want my line to be divided such that both are equal. Yeah, m is to n also I can say. I can say that both the paths are equal. So at that point, my P becomes simpler. My P becomes x1 plus x2 by 2, y1 plus y2 by 2. This formula is known as the midpoint formula. Yeah, P becomes the midpoint. This is the midpoint formula. And this is the section formula. Right? Any doubts? Anyone? No, right? Then, okay. Then we have something called as the slope of a line. Now here comes the main part from the coordinate geometry. Let's say this is my axis, y axis, and this is my x axis. I have a line, this. Okay. We don't have doubts till BFS, DFS. Okay. Okay, so I can just flow through it, right? Now I have a line L1. This L1 is making an angle, anti-clockwise angle with x-axis. I'll name it alpha. This alpha is known as angle of inclination. Angle of inclination. Now, slope is defined on angle of inclination. So slope we have is tan alpha, the tangent function of alpha. Always remember this is an anti-clockwise angle formed. Right? This becomes my slope. We denote this with m. We denote this with m. Now, there are some. Now, if we want to generalize this line L1, there are some notations that we use, or some predefined ways by which we write some formulas. The first one is, okay, before that I need to show how to calculate slope also. Okay. Let consider this line. I don't know the angle of inclination or anything, but what I know is I know 2 points on this line, which is, let's say, P1 and P2, x1 comma y1 and x2 comma y2. P2, this is x1 comma y, x2 comma y2. Now, if you want to find the slope of this line, if you want to find the slope of this line, what you can do is subtract the y coordinates divided by the x coordinates. Okay, this is how you find this slope when you don't have the angle of inclination. Now, the first way to represent a line is the slope point form. Slope point form. Now, what do we have in slope point form? As the name suggests, we have a slope and a point. M and P1 are given, right? Now, what I can do is I can write this as M is equal to y minus y1 on x minus x, right? These two are ungiven. These two things are not given. This we can apply and find. Second thing we have is 2-point form. As the name suggests, I have P1 and P2. Now, when I don't have this M, I don't have this slope. But using this formula, can I find the slope? I know that I have 2 points on the line. So I'll combine these two formulas, and what I'm left with is y2 minus y1, x2 minus x1 is equal to y minus y1 upon x minus x2, x minus x1, right? This green color is unknown, the orange color is known. Then the third way of representing a line is slope intercept form. Okay, this y-intercept, this is y-intercept. Can anyone tell me what is meant by intercept if I have a line like this?
The point at which it cuts the y-axis.
Right? This point is known as y-intercept. This point is known as x-intercept. How we generalize this equation is y is equal to mx plus c. M is the slope, c is the y-intercept. And these are given. Y and x are not given. And the last way by which we represent this line is intercept form. It is y by y-intercept minus x by x-intercept is 1. I just need to confirm this. Just 1 second. It is it is a positive here. Y divided by y-intercept plus x divided by x-intercept is 1. Is it fine? Then
Sir, I think that should be x by a plus y by b.
yeah, that's not a problem. The only thing you need to remember is y gets divided by y-intercept, x gets divided by x-intercept. This is y-intercept and this is x-intercept. Then this is what we were talking about, one line. Now we bring another line into picture and we define some terms which are parallel lines. Parallel lines. These are lines that never meet each other. Lines never meet each other. So an example of parallel lines is this, right? Now given that they are parallel, can I say something about their slopes? This is m1 and this is m2.
M1 equal to M2.
M1 equal to m2, correct? Now one more thing I need to specify is that their y-intercept is not equal. Why? Because if their y-intercepts are equal, they would be overlapping lines. Right? Now then there are perpendicular lines. Intersect at one point at only one point with 90-degree angle. That means if I have this line and I have this line, they will only intersect at one point with a 90-degree angle between each other. Now this is m1, this is m2, let's say. So I can say that m1 dot m2 equal -1. This is the condition of slope imposed on them, right? Any doubts here? Okay. One more thing, uh, angle between two lines. If you have two lines L1 and L2 with slopes m1 and m2, let's say I want to find this theta. So your theta is equal to m1 plus m2 upon 1 minus m1 m2. Okay, this is the angle between two lines. I hope this is clear. If yes, then we are done with week 2. If you have any doubts to ask in week 2, you can please ask. Yeah, there is one more topic, straight line fit. Error in science. Okay, yeah, correct. This is m1 minus m2 and this is 1 plus m1 m2. This is what you are saying? Yeah. Then we have straight line fit. This is a very simple but Very important thing when you study data science. Let's say you are given some points like this. Now you want to predict the value of the point which is not given here. So how will you predict this? Anyone? We try to form a line such that it satisfies all of these points with minimum error. Let's say I draw this line. Now, what is a straight line fit is this offset is there, no, right? This offset is minimum for the which of the straight lines is known as the straight line fit. That means minimum error or a line which produces minimum error. A line which produces minimum error is known as the straight line fit. Right? How do we find it? How do we know that this is an error? Let's say you have the equation of line as y1 equal to mx1 plus c1, or y equal to mx plus c. Let's say you have this equation and you have set of points x, y, and you are predicting this value yi, let's say. Okay, this is okay, this is given, this is given, this is using your line. Okay, now you find the difference between these two, that how much wrong your answer has gone. You find the difference between these two, you add all of them and you average them out. Let's say I have x1, y1, I have y predicted 1, I have y predicted 2, I have y2, I have x2, right? Then what I do is I find the sum of y minus y predicted, divide by total number of points. This is my sum squared error, SSE. This should be minimum. I hope this is clear. Anyone would like to ask anything? Square will come. Yeah, square will come. Now this is all that is given to you in the question. What is your error formula? What you should use for error? Everything will be given in question. Okay. Now then we move on to week 3, which is for quadratics. Quadratic graph. A quadratic function is generally of this form, ax plus bx plus c. If you see a function of this kind, this is a quadratic function. The only thing that we have here is a is not 0. Complete. This is your quadratic equation. Quadratic function. How will this quadratic function look like? A parabola. Upward opening or downward opening. These are the only two possibilities how will your quadratic function look like. Now the upward opening parabola occurs when a is greater than 0. That means this term is positive, and downward opening parabola occurs when a is less than 0. That means the term is negative. Right? Now there are finding roots of this equation. Finding roots of quadratic. How we do that? First we equate the function to 0. That means ax squared plus bx plus c equal to 0. right? We have two ways. First is factoring, second is formula. I'll write the formula directly. X is equal to minus b plus minus root of b square minus 4ac by 2a. This will give you two values. Both are your x. Right? By factoring, I'll show you with the help of an example. Let's say I have x squared plus 6x, okay, minus 6. X squared plus 6x plus 6. Can I do this? Wait. X squared plus 5x plus 6. I have this as my function. What I do is I find two numbers a comma b such that their product is equal to this third term c plus 6, and I need to have two numbers such that that product is plus 6 and their sum is plus 5. I need to take signs into consideration, right? Now I know that this number is a equal to 3, b equal to 2, correct? So now I can write this equation as x squared plus 3x plus 2x plus 6 equal to 0, right? I can write this as x equal to x plus 3 plus 2 x plus 3 equal to 0. Taking x plus 3 common, I get x plus 3 into x plus 2 equal to 0. Now this x plus 3, if x plus 3 equal to 0, your x is minus 3, and if x plus 2 equal to 0, your x is minus 2, right? These are two ways by which you find the roots of this quadratic. Is this clear? Okay. Now if you want to find whether the equation has a root, if you want to find whether your function fx equal to x squared plus bx plus c has a root, we check the value of discriminant, which is equal to root of b square minus 4ac. This term right here, this tells you whether you have a root or not. If your d is greater than 0, if your d is greater than 0, you have two real roots. If your d is less than 0, have you seen a root? Have you seen something like root of minus 2? Is this real? No, right? So that means this root is not here. I'm sorry. This is what you have to calculate, and you have to find the values. If you get d less than 0, you have no real root, and if your d is equal to 0, you have only one root that is real, right? This is the condition for roots to exist. This is a very important quantity. After this, we have maxima or minima of a parabola. Now if you know differentiation, well and good, you don't need to see this. I'll directly give the formula. Maxima or minima of a parabola, right? Take these terms as, if you have a less than 0, that means you have this graph, you have a maxima. If you have a greater than 0, you have this graph, you have a minima. Okay, there exists only one part. There exists only either a maxima or a minima. You cannot have both of them, right? If you have this thing occurs at x is equal to minus b by 2a. And if you want to find the value, you have to find just the minus b by 2a. The function value at this position gives you the maximum or minimum, right? Any issues in quadratic functions? Only one thing left is plotting. How do we plot? If you have x-axis, y-axis like this, let's say this is your first root, this is your second root. You just plot it like this. If your a is greater than 0, sorry, if your a is greater than 0, you have this part. If your a is less than 0, you invert the function, right? Anyways, you have three values that you can use to plot the graph. Use the two roots and the vertex. This point is known as the vertex. This is known as the vertex. Then we have polynomials. Polynomials are simply functions like quadratic but with higher powers. So any function of type like an to the power xn plus a n minus 1 xn minus 1 dot 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 ax plus a constant a naught. Okay, this is what a polynomial looks like. Now there are some properties of polynomials. Okay, you cannot find roots of a polynomial unless and until you know the division method. Okay, division method needs you. Okay, when you do this division method, no, you get something like x minus root 1 times another polynomial. Again, you apply division method on this, you get x minus root 2 another polynomial. Until and unless you get a quadratic here, you don't have a direct method to find the roots, right? I hope this is clear, this roots part, right? Let me take an example. F of x is x cube plus 5x plus 5x squared plus 6x plus
2.
2. Okay, let me take 2. Yeah. So I need to find the first root of it by trial and error method. Excuse me. Now by trial and error method, I need to try and put values from my side to check whether it satisfies this part. For most of the questions in your exam, you would just need to check this values. X is equal to either 1, 0, minus 1, 2, minus 2. These 5 values, if you check in this order, might give you the answer. Okay. Now I can see that x equal to 1 does not work. X equal to 0 also does not work. X equal to minus 1 will give me 0. F of x will become 0 for me, right? So this is my one of the roots. Now what I do is I divide this whole x cubed plus 5x squared plus 6x plus 2 by x plus 1. Minus 1 is my root, it will go this side and it will change the sign. Now, what multiplied by x plus 1 gives me x cubed, x square, right? Now multiply this whole thing by this, you get a x cubed plus x squared. Now we subtract it, right? So this is 4x squared. This comes down. Now I multiply this thing by 4x, right? To get a 4x squared. Take this, multiply this. You have a 4x squared plus 4x. Subtract this 2. You have 2x plus 2, right? Multiplied by plus 2. Go here. You have 2x plus 2. Change the signs. This becomes 0. So now you have this f of x. You can write it as x minus 1 times this x squared plus 4x plus 2. Now you know how to solve the quadratics. You can take it from here. Is this fine? Anyone facing any doubts? Okay. Then we have something known as multiplicity. Is there any problem, Harish?
No, sir.
Yeah. So then we have the topic of multiplicities. Now when you what I say, factorize this thing, no? You get something like f of x, x minus root 1, x minus root 2, x minus root 3 cubed, let's say. Okay, anything of this form. Now we have a term called as multiplicity of each root. Multiplicity is the number of times the root appears. As I can see that r1 appears only once, so r1 is a multiplicity of 1. r2 appears only once, r2 is a multiplicity of 1. r3 appears 3 times, so r3 is a multiplicity of 3. Now the sum of this will give you the degree of the root, a degree of the function itself. Degree means the highest power of the function, right? So I'll have 5. This is a function of degree 5. Okay, how do we plot this thing? This is very important. You first need to find the end behavior of the function. That means the behavior at minus infinity and plus infinity. Now how do we find the behavior at minus infinity? We see what sign will the function give. Approximately what sign will the function give. If I put minus 1 here, right? If I put minus 1 here, minus infinity here, I'll get a negative sign. Is that correct? If I put a minus infinity here, minus infinity minus any number will give me a minus sign only, right? And here if I put a minus infinity, I get minus to the power of 3, which is again a minus, correct? So that means this function in the end will give me 3 minuses. Now it is minus into minus into minus. Or you can consider minus 1 into minus 1 into minus 1. This is equal to minus 1. So in the end, I have a negative sign here. So that means at the negative infinity side, it is somewhere here. In the positive infinity side, this is a positive, this is a positive, and this is also a positive. So I'll have end behavior like this. Is it correct? Now what we do is, for a root, I'll write it, for a root of odd multiplicity, function goes linear, but for a root of even multiplicity, function bounces back. Function bounces back. Let me try this. I'll add one more term, x minus r4. Let's say I added this. Now the multiplicity has also changed and the number of roots has changed. Degree is same, right? This is, let's say, what is this one, right? Here I will not use y-axis because I don't know what my value of r1, r2, r3, r4 is. Let's say my r1 is here, r2 is here, r3 is here, and r4 is here. I'm just assuming, right? Now what I said is, a root of odd multiplicity, function goes linear. That means my function will go past like that only when it sees an odd root. So r1 is odd, r2 is odd, r4 is odd. So r1 is odd, r2 is odd, r3 is even, right? So my function will bounce back. This is just like quadratic, right? We had a quadratic, a parabola, so it will bounce back. Simple. Now how will you verify if this is correct? You start from one of the extreme, you go to the other extreme, and you check whether your initial calculation and the graph you drew gave the same answer or not. I hope this is clear, right? So I initially assumed that at positive infinity I'll get a positive, and the graph that I drew also gave the same result, so that means I am correct, right? This is supposed to be r1 here, not here, right? Are we done with the polynomials? Any doubt? Anyone wants to ask anything?
Sir, but if we have a multiplicity of 3, then still it will go linear.
Yeah, any odd multiplicity will go linear.
Okay, sir.
Yeah. Now we have week 5 functions. Okay. Week 6 is also functions. Week 7 is the, okay, done. Chal. Week 5. Now for week 5 functions are there, right? So a function is just a relation. It's only a relation with only one thing, with only one prerequisite or one condition. What are relations? We had two sets A and B, right? Here we have something called as domain and codomain instead of A and B. We have a domain, we have a codomain. It is just a relation that has been defined like this. The only condition is domain is always used. Domain is always used. Means all the elements in my domain are used. Or let me write it more clearly. Or in other ways, I can write it as a element from domain is mapped only once. Is mapped only once. That means If you have something like x1, x2, x3 in the domain, you have y1, y2, y3, y4, y5 in the codomain. This is a function. But if I remove this x3, right, this is now not a function because I want that this part is completely used up. This, if it is not used up, it is okay, but this thing should be used completely. Okay. This is what I mean by a function. Is this clear till now? The basic definition is this, that my domain is always used up. What is a domain? A domain is the set of x values that can be put into function that will give me an output. Or you can say domain is the set of x that exists. Codomain is the probable answer. Probable answer means answer is only from this. There is no other answer except this. This is known as codomain. And then we have the range. The range is the values of y which are used. That means the values of y which are used means all the outputs of the function. Now range is a subset of codomain. That is clear, no? If only these three are used, that means these three are my range. That's it, simple. Now, after this, we have some types of functions. 1 or injective. 1 is it injective function? Just a second. Injective function is injective function that makes, yeah, 1 is injective. No, onto is this surjective. No? 1 is injective function. What this says is, what 1 says is, let's say I have this function, but instead of this x3, this x3 is mapped to y2. This is possible. This is a valid function, right? Everyone agrees? Is this a valid function? Okay. Now what this 1 theory says that 1 theory says that for each element in my domain, it is mapped to a unique y in my codomain. So that means I don't have a repetition here. I have something like this or like this, but there is no repetition anywhere. This is what my function says. 1 function says. If you want to generalize it, you can say that your domain, cardinality of domain is equal to cardinality of codomain. Not cardinality of range, sorry. 1 input, 1 output. That is the range, that is the condition for function. That is the condition for function. Whoever was it? Radhan Para, right? 1 input, 1 output is for function, but this is 1 output for each input. Unique output for each input. Then we have onto function. What is onto function? Also known as surjective, says that my codomain is equal to my range. Codomain equal to range. Now, can this function be onto? Is this function onto? No, right? Now, in one function must have its code domain. Harish, I did not get your question.
Sir, I'm asking like here in domain x1, x2, and x3 are there.
Hmm.
So to be one, they must have their codaemon, or every function must like x1 have y1, and if x2 also have y1, then will they called one?
You are saying something like, अच्छा, first thing is codomain is defined for the function.
Hmm.
कोडोमेन एक ऐसा सेट है जहाँ से वैल्यूज तुम एज एन आउटपुट ले सकते
Hmm.
हो. नाउ यू आर सेइंग इज दिस थिंग, राइट?
Yes, yes.
नहीं, दिस इज नॉट वन वन. वन वन क्या कहता
Okay.
है कि अगर मेरा एक आउटपुट है
Hmm.
तो वो एक ही इनपुट पे होगा. इफ y1 इज माई आउटपुट, इट इज ओनली फॉर x1.
और ऐसा भी है कि डोमेन में जितने भी फंक्शन हो सबका कोडोमेन होना चाहिए.
नहीं, ऐसा नहीं होता. एक फंक्शन होता है एफ ऑफ एक्स करके एक फंक्शन होता है. तो ये
हम्म.
जो एक्स की वैल्यूज होती है ये डोमेन से आती है,
हम्म.
और ये जो भी प्रोड्यूस करता है वो कोडोमेन से आता है.
अब जैसे सर एक्स वन की हमारी इमेज हैगी, एक्स टू की भी डिफरेंट इमेज है और एक्स3 की भी है,
हाँ.
तो वन वन फंक्शन कहलाएगा, है ना?
हाँ,
अगर
मतलब दिस थिंग, राइट?
हाँ,
हम्म.
अभी तो ये वन वन हैगा,
हाँ,
लेकिन हमारी एक्स1 की इमेज है, एक्स2 की इमेज है, लेकिन एक्स3 की नहीं है, तो भी ये वन
तो
वन होएगा?
तो वो फंक्शन ही नहीं होगा.
अच्छा, फंक्शन के लिए सबकी होनी चाहिए.
फंक्शन के लिए डोमेन पूरा यूज होना चाहिए.
ओके सर.
ओके. एनीवन? If you are facing any doubts, please ask. Okay. Okay, I saw something. In one, every function must have its code. Okay. Now, if a function is one as well as onto, we call it as bijective. Just a name. Okay. Bijective function. Now we come to the main part, which is known as composite function. Composite function is like function inside a function. If I have fx and gx, right, what I do is f of g of x is my composite function. One way is this, or I can write f of g of x. Yeah, these are the two ways by which I write the composite function. How do we calculate it? First, start from the insides. Put x in gx. Whatever output you are getting, put that completely in f. Let's say I have f of x as 3 minus x. Let's say I have gx as x squared plus 2. I want to find f of g of x. Okay, what I do is I find first gx. After I find gx, my gx is x squared plus 2. Correct? Now this whole thing, I put it instead of this gx. So I have f of x squared plus 2. What was my f? 3 minus x, right? So instead of this x, this whole thing comes here. This is 3 minus x squared plus minus 2. This is your composite function. Not that important. But the question that comes from composite is domain and range. Domain of composite function. Let's say I have this function f of x as root x, g of x as x minus 3. Uh, yeah, let's say I have this thing. I find f of g of x. What is f of g of x? Root x minus 3, right? I hope this is fine. Okay. Consider that this is a function. Consider that x minus 3, I say let my hx equal to root of x minus 3. Now for this function to give me a valid output, what must be my value of x? What must be my domain so that I get a valid output from this thing? We know that inside of a square root, I cannot have a negative value. So my x minus 3 should be this, right? Or my x should be this,
Greater than or equal to 0.
greater than equal to 0. Sorry. Yeah. Is it correct? Right. Now, if I do this, I get this thing, right? Now, let me find the domain of a composite function. Now, this is very important because if you have a composite function and the function itself is not defined, then you will have a great problem. You cannot directly just find the composite function and directly find the domain like this. This is very wrong. For composite function, first thing you need to do is find x such that gx is defined. मतलब first thing you do is find domain of gx. Then from the range of gx, eliminate values that are not in domain of fx. Or you can do range of gx or domain of fx, you take an intersection. And then you intersect all three. If I try to explain you this f of g of x, this thing you have, right? If you want the composite function to exist, first thing is gx should exist, correct? If this is only not there, then composite is also not there. So first I find the domain of gx, correct? Now I see that the domain output of gx goes into fx. So that means my domain of fx and range of gx, this should be having some equality. It's not that I'll take any output from my gx and throw it into fx. That will be very wrong because gx will give me some invalid value that does not exist in range of x, a domain of f. Then that will give me a huge problem. So I'll do that and then I'll combine all of them to find my domain of composite function. Is this clear? Okay, right. Now then we have uh, I think test. Yeah, test we have then. What are the tests? There are two tests: horizontal line, vertical line. Horizontal line test, vertical line test. Horizontal lines means this thing, this, right? So if you have a graph of a function like this, you draw a horizontal line. What does this suggest to you? This, if you have a horizontal line test, and if your line meets at only one point, it is well and good. But if it meets at two or more points, a line at two or more points indicates that this is not indicates invalid function, right? So if you want to test whether this function is valid or not, do a horizontal line test. If you see anywhere it is touching at more than one point, that means it is an invalid function. Vertical line test is used for 1 1, checking the 1 1 functions. Let's say I have this graph. If I drop a vertical, I can see that it touches at only one point, right? A line at two or more points indicates many one function. I hope this tests are clear. Many one function, right? Mm. Inverse functions, they are simple. What are inverse functions? Inverse functions are nothing but a composition of f such that if you do this, you get x itself. Matlab, you can understand it like this, that if you do a plus b, you get something. But if you do a plus b, you get c. If you do c minus b, you get a. This is an inverse function. As simple as that. How do you find an inverse function? First step is check bijectivity. Check bijectivity. A function must be bijective. After that, replace x with y. Replace x with y and y with x in the function. Right? The y that you come up with after that, isolate y and x. I'll take a simple function and I'll show you. Let's say my y is equal to x plus x upon x plus 1. ये 1 1 तो है, on to also I think it is on2. Okay, that I'll leave it up to you. Check 1 1 and on2. After you check whether it is 1 1 and on2, then what you do is you replace x with y and y with x. So this becomes something like this. Now you isolate y. Xy plus y, xy plus x is equal to y, right? And then you have y is equal to x into y plus 1. I think, yeah, this is not correct. So I have something like xy minus y is equal to x. Y x minus 1 is equal to
Equal to
x.
minus x.
Minus x, yeah. Minus x. So that means you have y equal to minus x upon x minus 1. This is your inverse function. I'm just assuming that it is bijective. You check that once. You check this condition and then only do these things. But I was just showing you these two steps. I hope it is fine. Isolation means try to write that this y should be alone. This is your f inverse. Can I get a thumbs up if it is clear? Okay. Then we have two functions we are discussed. One is log function, other is exponential. Both are inverse of each other. Right? I'll talk about one, you will understand the second as it is. If you have exponential function is e of x, right? When, okay, let me take general exponential a of x. I don't know what to do. A of x, right? If you have, I assume that a is always greater than 0 and a is not equal to 1. Is it correct? What I am? No, no, no. Wait, wait, wait. A can be anything. A can be anything. X is greater than 0. And X. I think there is something wrong. Just give me 1 second. I'll check up the slides. Week 8, right? Week 5. Sorry. Mhm. Exponential functions is. Okay, yeah. Exponential functions is e to the power of x. Natural exponential function. Is there a general exponential function? No. We have e to the power of x. Right? Whenever my x is between 0 and 1. No, wait. There is nothing like that only. Yeah. Properties are if my e is greater, x is greater than 1. Why am I messing up?
हेलो
Yeah.
सर, मतलब आप मतलब इस टॉपिक में मतलब कौन सा प्रॉपर्टी सर, मतलब आप एक्सप्लेन कौन सा करना चाह रहे हैं सर?
Properties मतलब graph, domain and range.
नहीं नहीं, ये अच्छा,
Yashraj, I did not get the point.
मतलब अब मतलब इसमें आप समझाना क्या चाह रहे थे, मतलब वो हम
I समझाना नहीं. This week 5 you have exponential function, no?
यस सर.
So I just wanted to give you range, domain and graph. Simplified graph. How
For a
does your
graph of x,
exponential function looks like? This, no? Not this.
नो नो
This.
सर, वो कर यस.
for a greater than 1,
This is x is greater than 1, is it?
no, no,
यस
a greater than 1, a raised to x,
A raised to x,
for
सर,
a
ए
greater than
ग्रेटर देन 1.
a greater than 1.
1.
But I think there was a condition that this also was a condition, right?
नो नो सर.
Sure.
For
यस.
that condition, the graph will be different.
Okay, okay. I'm just messing up some things, but if you are telling that, I'll believe this only. Right? This point, the value of this point is always 1. Right?
यस.
Mhm.
Hmm. The domain of this function is real numbers. And the range of this function is also real numbers.
1 to infinite.
Uh, Not real numbers, sorry, the whole numbers. No, it is from 0 to infinite. It is 0 approaching here. It is like this, no?
यस.
Right? I hope for everyone this is clear.
यस सर.
Hmm. Now, similarly, there is a log function, log of a, right? If you draw the graph of this thing, no, you will observe that it is same as graph of e raised to the power x. The only thing is it is reflected from this line. It is like you place a mirror on this line, and whatever you get is your graph for log function. Huh. It is like this, right? Mirror at x equal to y. Yeah. What is this point?
0, 1.
0 comma 1, right? 0 1 1 comma 0, I guess.
Yeah, 1 comma 0.
1 comma 0. The domain for this is any number greater than 0, 0 to infinity. Range is real numbers. If you see, the domain and range interchange themselves. Is it clear till here, everyone? Week 5 and week 6 both are completed here. Now we move to week 7, limits.
हेलो
Yeah.
सर, बट ये लॉग का डोमेन सर वन, मतलब वन से इंफिनिटी होगा ना सर?
नहीं. Why?
क्योंकि लॉग जीरो कर देंगे तो सर उसका कोई
No,
वैल्यू नहीं।
log 0 नहीं. This is 0,
अच्छा,
but some quantity greater than 0. I am not putting a square bracket, no. This is like 10 to the power minus 10.
वो
0.0001 that is existing. So this is your inverse functions also, and this is week 5 and week 6 both. I hope this is clear.
यस
Limits. Okay. Limits, there are two types of limits. One is a series limit, other is a functional limit. What is the difference between these two? Series limit, there is only one limit, or we calculate only one side of limit. A to the power, this is a term. Here n tends to infinity. Similarly, not similarly. Why I am missing? This is a subscript n. This is a term of your series. A term of your series, and you calculate n tends to infinity. This is your series limit. Okay. Functional limit. What we do is, let's say you have a function like this. You have a function like this. Suppose. Okay. You want to find the limit at this point. What you do is you come from this side. You calculate the limit. You come from this side. You calculate another limit. This is called as left hand limit because you came from the left hand. This is known as right hand limit because you came from the right hand. This thing should be equal, so your function has a limit. Okay, these are two terms. This is your limit. Okay,
Yeah.
anyone facing any doubts?
No.
Okay, now what does your limit signify? Limit signifies no breaks in graph. Even if your graph is breaking, no, it is not breaking like let's say I have a function which is defined like this. Before x, before 0, or for x less than 0, this is what I have as a graph. For x greater than 0, I have this as my graph. Okay, as you can see that for my x equal to 0, I am not defining the function, but the graph is not breaking. It seems that from where it broke, it started from that point only. So this is what limit signifies. Your graph is not breaking that much. But if you don't have a limit, no, your graph would look something like this. Your graph would look something like this. There would be a big break here. Okay, this is what is your limit. Now how to calculate limits? There are some indeterminate forms. Indeterminate forms. Determinate forms. What do I mean by indeterminate forms? A form from which I cannot infer anything. Let me say you have 0 by 0 as an answer. Can you come to any conclusion from this point? This 0 will try to take your answer to infinity. This 0 will try to take your answer to 0. Right? You have infinity by infinity form. This denominator will try to take your answer to infinity. This will try to take your answer to 0. Correct? I wrote it. This is infinity and this is 0. Yeah. Let's say you have infinity minus infinity. You don't know which one is a bigger infinity. Right? You have 0 to the power of infinity. This will try to take you to infinity. This will try to take you to 0. Correct? These are the four values for which I don't have an answer. So what I'll do is I'll try to simplify my limit. Okay? These are the four forms. Are the forms, this you have to remember, these four forms. Okay? When you have these four forms, no, you try to simplify your equation so that you get either a finite number or infinity. If you have a finite number, limit exists. If you have infinity, limit does not exist. Okay? But these four forms, these are not of any side. This does not give you anything. Okay? Now let me take an example of a sequence a n. Let's say I take my a of n as minus 1 to the power of n. What will be the limit of this thing? Limit n tends to infinity minus 1 to the power of n. What will be the value of this?
One raised to infinite minus one raised to infinite.
Okay, you feel like it is minus 1 or 1, right? You don't know what it will be, correct? It will jump from minus 1 to 1, right? So that means I have to impose some condition on n. Are you getting my point? This is not giving me either infinity nor 1 nor any indeterminate form. So what I'll do is I'll consider my n is even. So I'm getting my minus 1 to the power of n as 1. If I give my n as odd, I'll get minus 1 to the power of n as minus 1. So for this, the limit does not exist. Clear? Limit does not exist. Right? I hope this is clear. Now, yes, Mayank, you want to ask something?
No.
Yeah. Uh, Now we have the topic of divergent and convergent sequences. I'll just simply tell you convergent is limit exists, or you can say that at infinity you can predict a value. Divergent means limit does not exist. Simple. Is it clear? Hmm, I hope this is clear.
Yes.
After this, we have subsequences. Subsequences is simply, I can say, a sequence filtered out. Just like subset, you have a sequence filtered out. Okay, this is a subsequence. Now, there is two main properties, or yeah, two main properties I want to talk about. First is, if you have a subsequence, let's say your a of n is your parent. This is the parent sequence, and this is your subsequence, right? Then this subsequence will tend to this value. Okay, this is one thing. Second thing is, for if you have a parent sequence that is divergent, subsequence may be convergent, right? But may be convergent. But if you have a subsequence that is divergent, that means your parent was also divergent. Simple. Is this clear? These are the three things that I want to tell you. First thing is, if you have a limit for the parent, you have the limit for the child. This is what it denotes by this. Second is, if you do not have a limit for this, if you do not have a limit for child, you do not have a limit for, you may or may not have a limit for parent. What am I saying? Yeah. And if you have a limit, if you don't have a limit for child, you don't have the limit for parent. I'll show you with the help of example. First one is intuitive. Second one, you see, this thing is divergent, correct? But if I filter out the terms of this type, minus 1 to the power 2n, will it become convergent? How many of you agree to this? How many of you agree to this thing? The statement that I made. The original was divergent, but if I filter out all the terms which have even power, the thing becomes convergent. Okay, come on, anyone. If you do not agree, you tell me why you don't agree. If you agree, you tell me why you agree.
सॉरी सर, वो अभी मेरा ये नेट इशू हो गया था लाइब्रेरी में, तो
See,
हम वो बाहर आ गए थे। तो सर क्वेश्चन क्या था सर?
yes. If you have this sequence, minus 1 to the power n,
ओके
this is divergent.
ओके सर।
Agreed? But if I filter out all the even terms, the terms which have an even power, will it become convergent? Are you getting my point? I have minus 1, 1, minus 1, 1, right? What I am
यस
doing is I am filtering out this ones. I am making it another sequence. Is it convergent?
Yes.
Convergent, right?
Yes, sir, it will be.
Hmm. So this proves my point, this second point. If your parent sequence is divergent, your subsequence may be convergent. Okay, if you have a bad parent, your child may be good or bad, but if you have a bad child only, you will have a bad parent for sure. Okay, I mean in terms of sequences. Okay, these are the properties of subsequences. I hope this is clear for everyone.
Yes, sir.
I hope I'm not missing anything on week 7 other than this. This is graphs and functions of one variables. Yeah, that is done. Graphs and tangents, okay. Limits of sequences, okay. Uh, Anyone facing any doubts? Hmm. Limit calculation is also an important topic. About asymptote. Asymptote is for functions. We'll come to that when we go to functions. Let me just get if there is a question from mock. Um, yeah. Is there any question related to limits and mock? Given that I don't care, this is the extras. Okay. Mm, I don't find any question to limits and mock. Okay, let me just bring up a question from my side. Mm, okay. Let's say you have a sequence. You have a sequence like mm, n. Sorry, n upon n factorial to the power 1 by n. Okay, this is your one sequence. The limit for this limit of an is e. Okay, now find limit n tends to infinity for 2n plus 1 upon this is ln 2n plus 1 upon 2n plus 1 factorial to the power 1 by 2n plus 1 plus ln 3n upon 3n factorial to 3n by 1 by 3n. This is what you have as a question. How will you solve this? If you see, if you see this part, this is my this is my odd term for a sequence, right? Odd term sequence. That means if I have if you say this, what is this 2n plus 1? I can generalize it. If I put my n equal to 0, I have 1. If I put my n equal to 1, I have third. N equal to 2 gives me fifth. N equal to 3 gives me seventh. Is it seen that I take alternate terms. I have alternate terms, right? So if my an goes to e, my alternate terms of an will also go to e, correct? So that means this whole thing, the inside part, will go to e, correct? Right? So that means this whole thing becomes 1 for me now. Is it correct? Now similarly, if you see this part, this is my third term in the sequence. The third term, the sixth term, the ninth term, the 12th term. So this is also a subsequence, right? So that means this will also go to e. Now answer is 2, correct? Is this fine? After that we have this functions limit. I told you how do we calculate them, right? We calculate two sides of limit, LHN and RHL. The only thing that we do here is we have different, is we calculate LHN and RHL for functions. Simple. The calculation type is same, everything is same. But why we have this LHL and RHL? It's because of the function choice. Now this limit question comes in piecewise functions, right? So if you have a function which is like this, these are two different functions. Which function to choose, this will be told by LHL and RHL. So LHL occurs here. So that means I'll choose this function definition. RHL occurs here. I'll use this function definition. Okay. I hope this limits is clear as such. Then we have continuity. This is built up on top of limits. When you have a limit for function, no limits for function, if they exist, then we check for continuity. Continuity says that f of x is equal to limit at x. Right? Now since this has to be defined, I can write my continuity as LHL equal to RHL equal to fx. Now what does this signify? This signifies that graph can be drawn in one stroke or without lifting my pen. Okay. Let's say I have a function f of x. This is sine x. X is less than 0. 0 when x is greater than 0. And 2x by 3 when x is, okay, this is x equal to 0, this is x greater than 0. If I told you to find the limit at x equal to 0, if the function is continuous at x equal to 0, what you will do? Limit x tends to 0 minus LHL. You have limit x tends to 0 plus RHL, right? And you have f of 0, right? Now which function definition I'll use in the first part? Will it be 1? Will it be 2? Will it be 3? For this part, which function definition will I use?
First.
first function definition, right? So for this, I'll get sine x tends to 0. Now I can remove the minus sign because I know the definition what I'm using. For 0 plus
Third.
third, limit x tends to 0, 2x by 3. And the last one will become second, which is 0, right? Now I have a 0 equal to 0 equal to 0. That means the function is continuous. Okay, this is continuity. I hope this is clear. Any doubts? Now after the function is clear, continuous, we move on to differentiability. I think continuity is only the topic, right? Yeah. Okay, then we have differentiability. I'll write it.
Sir,
Yeah.
in continuity, whether it is LHS and LHL
Uh-huh.
and RHL,
Mhm.
uh, we just need to put the value in the function.
If you put the value in the function and you get a direct value, well and good.
Mm.
But if you get any of the indeterminate form, you have to solve further.
Can you just give an example for
Okay.
solving?
Uh, Let me do this as sin x by x. Right?
Yes.
Now this function will not be continuous, I'm telling before only. But now you have something like sin x by x, correct? Now if you see, this is 0 by 0 form, right? This is 0, that I don't care, I'm just solving this part. Since this is 0 by 0 sin x by x, I need to do something. Now do you know about L'Hospital's rule?
No, sir. I'm confused in that.
No, but you know no L'Hospital rule is used for solving limits.
Ah, yes.
What we do there is, we take the denominator, different numerator, we differentiate it. We take the denominator, we differentiate it, right? So what is the differentiation of sine?
Cos x,
Cos x. What is the differentiation of x?
1.
Now you have something like limit x tends to 0 cos x. What is the value of this?
Cos 0, 1.
You got the answer. Now
Yes.
you will put 1 here. There are many ways by which you can solve this thing,
Mm.
but as hospital rule is simplest of all. Come to L hospital's rule when we discuss differentiation, but for now, I hope this is clear, no?
Clear, sir.
Now this is continuity. Now based on continuity, we have differentiability. So what we do is, a continuous function or a continuous function, if limit x tends to 0, x tends to a, or limit h tends to 0 plus, okay, this is something like, you have a point A and you are finding that if you go up on that A, how will the function change? It is something like that. That if you have this function, this is point A. If you go somewhere up, how will this value change? This is only what we are calculating here. If you see f of a plus h minus f of a by h, right? This is also a plus h minus a, the difference between the points, delta y upon delta x. Okay, this is what we will calculate here. Now this is h tends to 0 plus is equal to limit h tends to 0 minus f of a minus h minus f of a upon a minus h minus a, so minus h, right? This limit is equal, then the function is differentiable. This is called differentiation by first principles. Is this clear? Now if you have told that this is a differentiable function, you can directly differentiate it. D by dx of fx. This is how we show differentiation, right? Some common differentiations are d by dx of x to the power of n, n x n minus 1. D by dx of sin x, it's just cos x. D by dx of cos x minus sin x. Okay, d by dx of ax plus b, or d by dx of fx plus gx. This you can break in the middle. You can write it as f dash of x plus minus g dash of x. Right? Okay. Please solve by differentiability for us. Okay, first let me complete this. This is one thing. If you have d by dx of multiplication of two functions, right? Differentiate the first function, leave the second one as it is, then add it with the differentiation of the second function, leave the first one as it is. Okay, and the last, d by dfx of fx by gx. How you do this? Differentiation of denominator, denominator squared you put there first, differentiate the numerator, keep the denominator as it is, subtract differentiation of the denominator, keep the numerator as it is. These are some formulas that you need to remember, right? Now one exercise for you. Find differentiation of 10x using the division rule. Using this you can try it. Soumya, what you are saying, this fx equal to sin x by x. I'm not getting the question.
fx equal to sin x by x if x equal to 0
Hmm.
and 1 for x, sorry, sin x by x, x
Hmm.
equal to 0 and 1 for x not equal to 0.
Try. I did not get it. X equal to 0 and 1, but x not equal to 0.
Wait,
Yeah, check it. Till then, anyone any doubts in this part? This thing? If not, try this d by dx of. Okay, yeah, I missed the chain rule. Very important chain rule. F of g of x. If you are asked to do this thing, no? If you are asked to differentiate this thing, you first differentiate the outer function, keeping the inner one as it is. Then you differentiate the inner function. Okay? This is chain rule. Now, if you have this, I have an f of x. Sorry. f of x is this is equal to x cubed 4x squared sin x cos x plus sine of x cubed. Differentiate this function. And Soumya, did you get the question?
Sin x by x for x not equal to 0.
Sin x by x for x not equal to 0.
And 1 for x equal to 0.
Uh-huh.
This is a function.
F of x by x is sin x by x. Then x is not equal to 0.
Mm.
And x equal
1.
to 1.
No, no, no. F of x equal to 1 when x equal to 0.
Hmm. F of x equal to 1 when x equal to 0.
And sin x by x when x not equal to 0.
This is equal to 1. Sin x by x, sin x not equal to 0.
Wait, wait, wait.
Array, you share the screen only. Okay, sure. For everyone, let me just show. Sin x, अच्छा, okay, piecewise function. X not equal to 1, okay. Solve for differentiability. Is it?
Yes.
Okay. This is 1 for x equal to 0. This is what your pieces are, right? Okay. Let's first solve this one, then we'll solve that one. One answer I have is 3x squared plus 8x minus sine squared x. Okay. Plus cos squared x. Okay. Plus 3x squared cos x cubed.
True.
Anyone who is getting a different answer from this? Anyone with a confusion here? Okay. So you want to test for differentiability. For this, you have to do LHD equal to RHD. LHD limit x tends to 0 plus x tends to 0 minus f, not x, h, f of a plus h minus f of a by a, h, correct? This is f of a plus h minus f of a by minus h. This is f of h tends to 0 sine a plus h by a plus h minus 1 upon h, right? Only this side of equation I'm solving first, correct? Then we can write it as sine a plus h minus a plus h by h into a plus h. Here your a is 0, right? A is 0, so I can write it as sine h minus h by h squared. Barabar. Now if I put my h as 0, I'll get 0 by 0 form. So what I'll do? L'Hospital rule. This becomes a cos x for me. Cos h minus 1 upon 2h. Now if you do this, you'll get 1 minus 1 by 0. Again 0 by 0. Again apply L'Hospital's rule. This is minus sin h upon 2. So this becomes minus 1 by 2. right? Any doubts in this part? Is it a doubt, Soumya?
No.
Okay. Similarly, if you come this side, here I have to do this minus. This is sine of a minus h minus 1 a minus h upon h. Or I can say sine of minus h minus 1 minus h into minus h. Right, I think this is what we have, minus h into minus h. Here,
Minus h minus 1.
this is
Sign of minus h ready.
okay. Uh, Now I have minus sin h minus h square, right? Same thing I'll do. This is minus cos minus 1 upon minus 2h. 0 by 0 will only come, so I'll Hospital's rule. This is again 0 by, this is minus 1 in minus 1 upon minus 2. So, mm, so this is minus 2 by 0, infinity. So I don't think limit are differentiable. This is differentiable. Okay. This is not differentiable, at least for now. If anyone challenges this, I'll be more than happy. So this is what differentiability is. Now, just like we talked about inverse functions, no, we have inverse of differentiability, which is integration. Okay, before that, let us talk about tangents and all. Tangents and differentiation. I hope you all know what tangent is. If you want to find the equation of tangent, or you want to find the slope of tangent at x equal to a, this is given by f dash of a. This is what is a slope. Now if you have an asymptote, what do you mean by an asymptote is the function tries to approach the value but cannot achieve it. This is what is meant by asymptote. If you have a function e to the power x, no, it tries to achieve 0 but it cannot achieve it, so this is asymptote. Is it clear? These are the two parts, and we are completed of differentiation. Differentiation gets over here. Okay, then the inverse of differentiation is integration, right? Integration is simple, it does not require any checks. The things that you need to remember is this: if you have a to the this f of x integrated at this limit, okay, let us do without limits first. If you integrate a to the power of x to the power of a, right, this is x to the power of a plus 1 by a plus 1. Okay, then you have something like integration of sin x is minus cos, integration of cos is minus sin, integration of cos is just sin, and there is a constant term here in indefinite integration. uh, yeah, then you have something known as an important property. which is when you have something like this uv dx. These are two functions. These two you have to take from the islet rule. Islet means inverse, logarithmic, algebraic, trigonometry, exponential. Inverse, log, algebraic, trigo, exponential, right? The one that comes lower, the one that comes below in the series is v, the one that comes above is u. And then the value of this thing is u integration v dx minus integration of u dash integration of v dx. This will give you direct value. This is what you need to learn in integration.
So once repeat, that's product rule.
Product rule, right? U and V are two functions. Now, out of these two functions, you need to identify them. Let's say U is algebraic. Let's say one function is algebraic, one function is exponential. So your V becomes the exponential and U becomes the algebraic. Only the notation. Now what you do is you integrate V and you multiply it with U. Then you integrate V again, you multiply it with the derivative of U and you integrate the whole thing. This is what will give you your answer for this UVDX. Okay,
Yes, sir.
this thing. Now, this is indefinite integration. When you use definite integration, when you definite it, that means when you get limits to it, right? It is same as indefinite integration, but the function that you have here, the capital F, how you do it is you do f of the upper limit minus f of the lower limit. And this thing will give you the area under the curve. Area under small fx. Okay, this is definite integration. Everything is same. The only thing is we are building up a metric on it. Then we move on to graphs. Any doubts anyone is facing up till here?
Hello, sir. Hello.
Eh, is there a doubt?
Yes, sir.
Yeah,
Sir, I
ask.
have a doubt in substitution
Which question?
formula. Substitution formula.
Substitution formula. Acha. Do you have a question?
No, sir, I have only formula.
Substitution means which formula? I don't get you.
Okay, sir, I can share my camera.
Is it possible or is it logged for you? I don't know about that. Uh, okay, yeah. Share the screen.
Wait a minute, sir.
Okay, just 1 second. F of gx, g dash x. Okay, got it. Is my screen visible? So what does that substitution formula says is, if you have a function like this, f of x, okay, if you have a function like f of gx, f of gx, g dash x, if you have something like this, okay, Then what you can do is you can replace g of x with a t. Why? If you see, if you differentiate this d by dx of gx with a t, you get this thing, right? Now this is g dash x into dx equal to t. One thing you keep in mind is when you integrate, no, you only have a single variable. If it is x, it is all the way x. If it is t, it is all t, right? So if you see, this is ft into g dash x into dx, right? But I don't want this. I want here dt, and I want here something of t. So I develop a relation between both of them, and I get this thing, right? Now I can see that this thing can be replaced with a dt. So you have ft dt. This is your final. This is clear. Now, is there a doubt in this?
Yes.
Then we come to graph theory. I'll only discuss some important things. Uh, if you have specific doubts, you can ask them, or I'll discuss BFS.
I was just
Sorry,
well, the main sums I got about like
Riemann sums are not that important. In end term, they don't ask much questions on Riemann sums. We have a BFS, DFS, Dijkstra, and I'll do prims or crystals. Apart from this, if you have any doubts, kindly say it now.
सर मतलब मैं ये ग्राफ वाला टॉपिक नहीं पढ़ा हुआ हूँ कुछ पढ़ता हूँ तो फिर
Okay, but there are two more topics. One is minimum color and topo. I'll not take this two because already it is a 3 hour long session, right? These two are not that hard, so you can watch the lectures. But this four I'll cover for you. If graphs basic concept, I hope you know. I'll take short graphs only, so it becomes easy for. Okay, this first thing is BFS. BFS, what we do is we start from thing, we explore its neighbors one by one. If you see the example, I'll tell you. In BFS, we use something known as a stack, I guess. Okay, BFS uses stack or queue. BFS uses a queue. So, what is the purpose of a queue? Queue means last in, first out. First in, first out. Sorry. So first in first out means if I have a queue something like this, if I have something here, if I have something here, if I have something here, I add here, but I remove from here. Okay, it's like you are purchasing a ticket and there is a queue of people. Simple. Now we maintain something known as visited, which tells me whether I have visited this index one or not. Okay, and we have a queue. Let's say I start from this index A. I start from A. Okay, then I have visited A. I am marking it visited. I add all the neighbors of A to my queue. So what are my neighbors of A? B, C, and D. Right? Now my A is visited. Now I come to the queue. I extract the first element. I extract the first element. I extract B. Now I am at B. What are the neighbors of B? C, D, and E. So C and D are already there. E also I'll add. Okay. And I mark B as visited. B is over. I can remove B. I come to C. Right. C has no neighbors. C has only one neighbor, which is B and A. Both are visited, so I'll not add anything. Then I'll take out D. I come here. I have two neighbors B and A, they are visited, so I'll just mark it as visited and do nothing. Then I come to E. E has only one neighbor B, which is visited, so I go E. This is BFS. What BFS do? BFS does a shallow search. It is here. It will take all paths from here. It will take all paths from here, all paths from here, and all paths from here. This is what BFS looks like. Okay. Now if I use the same graph and do a DFS, what DFS does is it will take one path, go inside, come back, again take a path, again go inside, come again back, and then do like this. Okay. This is what is DFS. For DFS we use stack. Stack is first in, last out. So if I have a stack, if I add something here, I'll remove that part here. Right? If I take the same example, I mark a visited index same. I come from A, right? I visit alphabetically. I have B. I go from A to B. I maintain a stack here only. I go from A to B, A to C. Okay, wait. Go from A to B, right? Correct? I go from A to B, C, and then D. My A is visited up till now. Okay. Then from here I remove D. I see my neighbors of D are B and A. So I'll just append D. Similarly, I'll remove C. I get C. I only see neighbors are B and A. Then I remove B. I see neighbor is E also, so I'll add E. I'll remove E and then I'll do here. This is DFS. This is what BFS and DFS look like. The only thing is the data structure we use. For BFS we use a queue, for DFS we use a stack. And the neighbor you bring out is the choice of the data structure. Okay. Then we have single source shortest path. Single source shortest path. If you have something like this, if you have this, okay, there is some cost for going, and you want to find the cost of each vertex from this vertex, we use SSP, single source shortest path. And the Dijkstra's algorithm is one of the best algorithms out there. What you do is you think of this as a tank, and all these are taps. What you do is you open the tap here. It take 10 minutes to fill the tap here, right? So you take this analogy and follow this. So 10 minutes here. So at 10th minute this will fill. At 20th minute this will fill, right? And at 38th minute this will fill, right? Now which is the lowest among these three? 10, right? So I'll update the values from here. This is 40th minute, right? And I cannot see anything else. What is the shortest among all three now? This 20. right? Now this 2020 is 40 and this 2010 is 30. So I'm getting the same value. So that means this is the cost of me going from this vertex to all of the other vertices, right? Is this fine? If you have any doubts, please ask. Huh? This is what single source shortest path. Now, if you want multi-source shortest path, they don't ask you in exam. They don't ask you in exam. I have not seen any question come from two terms, if I'm not wrong. Yeah, two terms. I have not seen any question. But even if they ask, I'll suggest you go through the Bellman-Ford thing. I suggest you go to the Bellman-Ford algorithm once from the lectures. It is, I think, 11.3 or something. 11 point, no wait, 11.7. Lecture 11.7. Okay. Yeah, Mayank.
Sir, can you solve the mock test question number 11 and 13?
Question 11, question. Yeah, minimum cost spanning tree, no? Okay, just give me 1 second. Minimum cost spanning tree, it looks like this. Okay, for minimum cost spanning tree, I'll take a simple example and tell you, and then I'll solve that. If you have something like this, I'm telling you the simplest algorithm of all, so you can solve the spanning questions. Okay. They are connected by some weights. They are connected by 10, 20, 2, 4, 6, 8. This is what I have. Rough example. What you do is you draw each vertex and you give them a component number. Give them a component number 0, 1, 2, 3, 4. Random. Now pick the smallest edge with the smallest weight. A to D. This is a 2, right? Now these are in the same component, so update the component. Now carry this step until you reach a single component for all the graph. Okay. If you have something which exists in the same component, we do not take that edge, we ignore that edge. Okay, this is how you do it. A2 is 4. So now this also become in the same component. Then I have A2CS6. This came in the same component. I have C2E as 8. Both are in 0, so I'll ignore that edge. I'll move forward. A2B is 10. Write 10. Get it into component and it is done. Okay. This is how you solve this type of questions. I'll just share the question. Okay. This is what I have, right, as my example. Now if you see, just give me 1 second. Yeah. I don't want it. You have something like this, right? What I said, give each of them a component number. This is 0, 1, 2, 3, 4, 5, 6, 7. Right? Take the minimum edge. This one, update the component. This becomes 0. Another minimum edge, this 0. One more minimum edge. This is not of use to me, right? This I'll take 0. Any 3 here? No. 4? Yes. I'll take this thing, right? 5, shall I take this? No, right? Both are in 0 0. Then I have this 6, both are in 0 0. I have this 7, both are different, so I'll take a 0 0. Right? Then 8, this is again in 0 0. 9 is not in 0 0, so this I'll take. Okay, yeah, this 8 is also there, so I'll need to take this also. Right? Now all are in 0 0, so this is my answer. 1 plus 2 plus 3, 4. 3, 3, 6, 10, 17. 17 and 17 is 34. Is the answer 34? Mayank?
Yes, sir.
Yeah. So this is, you update the components and find the values like this. Okay. So that is an MCST concept. What was the other question?
The 13th one.
13th one. Okay. We need to matrix multiplication. Okay. What is that? Okay. Matrix multiplication. Just give. If this is a matrix multiplication, I'll just tell you the concept. What you do is, to find this value, no, this value, right? You take this row and this column. First element of this row, first element of this row, that is this, and this whole column, which I take with red, is to be multiplied. Then take the second element from this row and this column, third element, and multiply them. And you add all of the products that you get. Okay. So for this question, if I'm calculating this, no, I'll take this column and this row, right? So I'll have 0 into 0, 0, plus 0 into 0, again a 0, then 0 into 0, a 0, 0 into 0 is also a 0, and 1 into 0 is a 1, is a 0, sorry. Right? This is what you have. Second is this, right? So that means this column and this row. 0 into 1, 0, 0 into 1, 0, 0 into 1, 0, 0, 1 into 1, 1, and 0 into 0, 0. So you have 1. Now it is asking 2a plus b, if I'm not wrong, right? Alpha is 0 and beta is 1. So you have the answer as 1. Okay? Right? Mayank?
Yes, sir. Thank you.
So that's it from my side. If you have anything to clarify, please ask, or we may close this session then.
Sir, which topic is highly weighted?
See, I'll suggest that graphs and integration, the week 8 to 12, that is more important, about 60% weightage.
So graded
Sir,
assignment, mock test are enough for it.
Yes, more than enough.
इंटीग्रेशन में ज्यादातर क्या एरिया वाले क्वेश्चन आएंगे?
इंटीग्रेशन में एरिया वाला क्वेश्चन आई कैन नॉट से, but one question comes from integration. If I take a PYQ and show you,
हम्म,
just give me 1 minute, I'll just take a question on that. Max, no? Max, yeah. Okay, okay. No. Hmm. Yeah. Last time you did not had an integration question only. But even if you get integration question, no, they will ask you very simple question like I have a function, I differentiated it, I got this function. What was the original function? It will ask you like that.
Okay, sir.
Okay, I have a polynomial function. I got it by differentiating another function which was of this type. What are the value of my coefficients?
Okay,
It,
sir.
yeah.
Got it.
Mayank, you are asking something?
No, sir.
Okay. So I hope this was it. I hope this
Thank
session
you, sir.
and all the best for your exams.
Thank
Thank you
you,
so
sir.
much, sir.
Not sir, Harsh only. Thank you guys.
Thank you. Thank you.
I'll close the session and
Thank you, sir.
Thank you, Harsh.
thank you, man. Thank you, Harish. Thank you, Shiv.
Thank you. Bye.